Good evening, Sendamichelvan. Good evening, Ram Prasad.
Good evening, ma'am. Good evening, ma'am.
ஒரு 2-3 minutes வெயிட் பண்ணலாம் கண்ணா, அப்புறம் கிளாஸ் ஸ்டார்ட் பண்ணிக்கலாம். Good evening, everyone.
Good evening, ma'am.
Good evening, Kanna. So we'll start the session. I could see few new students here. Sharmila, Janani, Subhaya, and all that. Okay, fine. Even Ram Prasad seems to be a new student. Fine. Yes, Ram Prasad. Are you new to this class?
Yes, ma'am.
Fine. May I know which class you are in?
Chemistry, ma'am.
You're in which standard, Kana? 11th or 12th?
11th, ma'am.
11th standard,
11th
okay.
by max.
Okay, fine. How about Janani, Sharmila?
Yes, ma'am. I'm also a new student.
Fine. You're in which class, Janani?
I'm in grade 11, ma'am.
Grade 11, okay. Where are you from?
I'm from. You mean the school or the place, ma'am?
Place.
I'm from Coimbatore,
Coimbatore.
ma'am.
Which school you are in?
SNS Academy, ma'am.
Fine, okay, right, Kana. How about Shatmila? Which class you are in?
Ma'am, I'm studying 11th standard.
11th standard, okay. Subbaya. Fine.
What, ma'am?
Left the meeting. Okay, okay. I was talking about another student, Kana. Fine. So we'll start the session. So we'll be starting with 11th standard syllabus today. So what are all the topics you already familiar in 11th standard? As far as chemistry is concerned, I'm talking about a chemistry subject. What are all the topics you're familiar with in 11th standard?
Ma'am, about atoms and atoms,
Fine.
atomic theory.
Super. Yeah. That is your second chapter, right, Janani?
Yes, ma'am.
Okay. Apart from atomic structure, what all the chapter you guys are familiar with? Kana, you guys can talk. Why you guys are so quiet? I'm just asking about the chapter's name. That's it. Atomic structure. After which, that is your second chapter, right? What about your first chapter?
Ma'am, law of conservation of mass,
Okay. Love.
states of matter.
Okay. Fine. I'm going to share my screen. Is my screen visible?
Yes, ma'am.
Right.
Yes, ma'am.
So, from today onwards, we'll be starting with 11th standard syllabus. So, in 11th standard, as far as chemistry is concerned, we have three branches. Like we'll be having inorganic chemistry, organic chemistry, and physical chemistry. Okay. So, first we'll see what are all the topics we have in 11th syllabus. Okay. So, first chapters, some basic concepts of chemistry. Second chapter is atomic structure. See, I think there are few students from state board. May the topics may differ, but under each chapter, the concepts will be same for CBSE and state board students. So you guys need not worry. Anyways, we're going to cover all the concepts from both state board and CBSE. So you guys don't worry. The topics may, the name of the chapter may vary, but the concept under each chapter will be the same. Okay, we're going to discuss in depth. So you guys maybe from your CBSE or from state board, you guys need not worry. Okay. So first chapter, some basic concepts of chemistry. Second chapter is atomic structure. Third chapter is, any guesses? Definitely you would have studied, right? How about third chapter? Periodic classification of elements. Fourth chapter is chemical bonding. Very interesting topic is this. Very interesting and very important topic too. Fifth chapter is thermodynamics. Sixth one is equilibrium. All these chapters are from volume 1. Okay. And from volume 2, the first chapter is redox reaction. Next chapter is general organic chemistry and hydrocarbon. So, today we'll be starting with the chapter called Some Basic Concepts of Chemistry. Okay, so in this chapter we'll be studying few fundamentals from chemistry. All these fundamentals, all these concepts, all these basics will be very very useful in understanding the rest of the chapters in 11th standard and 12th standard. Okay, so this chapter is really very very important to understand your rest of the chapters. Okay, please concentrate here. Before getting into the chapter, I want you guys to interact with me. Okay, whenever I'm asking question, you just please react. Okay, I'm not expecting any perfect answers from you. You just react, or you just tell your point of view. That's enough. Okay, shall we start the session? Shall we get into
Okay.
the chapter?
Okay, ma'am. Let's start.
Fine, fine. So we'll be starting with some basic concepts of chemistry. So in this chapter, there are very, very, very important topics like mole concept, um, to calculate empirical formula and molecular formula, limiting reagent, and finally solution and concentration. These are all the topics under basic concepts of chemistry where we can expect numerical. You can expect numerical from for your Neet as well as JE. So first we'll start with mole concept. Kana, you are familiar with this term mole, right? What is this mole? The core basic like matter, elements, compounds, atoms, molecules, everything we have discussed in our very first class, right? If any of you guys missed that, please see that in our YouTube channel. Okay, so we have discussed about what is matter, element, compound, stability, how to convert one unit to another unit, and all that. We have discussed all these basic core fundamentals in our very very first class. If you guys didn't attend that class, please see in our YouTube channel. Okay, fine. Now we'll start with moles. Okay, which is very very important. We can expect question from mole concept both in your Neet and JE as well. So what is mole, Kana, in chemistry point of view?
Ma'am, the amount of substance that contains
Mm.
0.6.022 into 10 power 23.
Yes. So, what is one dozen? In our regular life, we'll be using this term, one dozen.
12
One
number,
dozen of apple is something. Yes, Kana?
12 apples, ma'am.
12. So, if I have 12 apples, then it is one
One
dozen of
dozen
apple,
apples.
right? If I have 12 pen, then that is one dozen of pen.
Apples.
So, instead of this number 12, I'm using the term one dozen. If suppose I have two dozens of apple, then how many apples I have?
24 apples, ma'am.
24 apples. So instead of the number 12, I've been using the term dozen. Similarly, in chemistry, we are using the term mole instead of a number called. There is a name for this number, right?
Avogadro number.
Yes, Avogadro's number. So if I have 6.023 into 10 power 23 numbers of something, then I'll call it as 1 mole. Is it a small number or a bigger one?
Bigger one.
Sorry, Rakshan.
It's bigger one number,
Yes,
ma'am.
a very, very big number, right? So if I have 6.023 into 10 power 23 hydrogen atom, then I can call it as 1 mole of hydrogen, right? Fine. Next. Now we know what is mole, and this 1 mole of something contains 6.023 into 10 power 23 units of something, right? Fine. Now, for example, I am asking you to take 1 mole of water in a lab. Okay, I'm asking you to take 1 mole of water. Actually, what is 1 mole of water? What is the formula of water?
H2O, ma'am.
H2O. Okay. I'm asking you to take 1 mole of water. What is 1 mole? Obviously, we know it is 6.023 into 10 power 23 water molecules, right? But is it possible for us to see one water molecule? Unfortunately, we cannot. Then how we can count exactly these many number of water molecules to get 1 mole of water? It is impossible, right? So we know 1 mole of H2 is nothing but Avogadro number of water molecule, but it is not in a measurable quantity. So we have to convert this number of mole in a to a parameter where we can measure. For example, if I'm asking you to take 10 gram of water, is it possible for you to take or not?
No, ma'am.
If I'm asking you to take 10 gram of water,
10 grams.
we can, right? So if number of mole is converted into weight, then it is possible for us to measure and take it, right? So now I'm going to convert this number of mole into weight. So this is a very, very famous formula, that is the relationship between number of moles and mass, that is weight. Number of moles can be represented with an alphabet small n, which is equal to given mass divided by molar mass. That's it. What is this molar mass, Kana? What is molar mass? For example, H2O. H2O is an element or compound?
Compound, ma'am.
Compound. So for compound, the molar mass is molecular weight. So what is the molecular weight of water? Have to calculate the
18.
molecular weight of water. Yes. See, weight of the molecule is molecular weight. As simple as that. See, as far as water is concerned, this got two hydrogens and one oxygen atom. Weight of hydrogen is 1. What is the unit, Kana? This also you have this we have discussed in our very first class itself. So weight of 1 mole of hydrogen is 1 gram, right? So this is 1 gram per mole, and oxygen is 16 gram per mole, right? So this water molecule contains two hydrogens, so 2 into 1 gram per mole, and oxygen is only 1, so 1 into 16 gram per mole. So totally the molar mass of water is 18 gram per mole. Now I've asked you to take 1 mole of water, so number of moles I've given as 1, which is equal to, I have to calculate the mass. Molar mass of water is 18 gram per mole. That's it. So if you cross multiply this, mass is equal to 18 gram. So if you take 18 gram of water, then that is 1 mole of water, and that contains 6.023 to 10 power 23 molecules of water. As simple as that. So we have to know the formula to convert number of moles to mass or mass to number of moles, and here is the conversion. So as far as mole concept is concerned, we have to be familiar with this flow chart. Weight, we can convert this weight into number of moles,
Govinda.
and we can convert number of moles to weight also, and the relationship or the formula is number of mole is equal to given mass divided by molar mass. Kana molar mass is the common term. For the element we'll be using molecular mass, and for the element we'll be using atomic mass, but generally we'll be calling it as molar mass. Okay, fine. So now we can convert weight into number of moles and number of moles into weight. And similarly, we can convert number of moles into number of chemical species. Have to convert. I have 1 mole of water. So how many water molecules I have? 6.023 into 10 power 23 water molecules, right? If I have 2 moles of water, then how many water molecules I'll be having? We have 2 moles of water. How many water molecules I'll be having?
12.02.
So you have to multiply the Avogadro number with 2, right? So if I have number of moles, and if you want to convert number of moles into number of atoms or number of molecules, then you have to multiply it with Avogadro number. See, Avogadro number can be represented with an alphabet capital N with the subscript A. Okay, and if you want to convert number of chemical species into number of moles, then you have to divide the total number of chemical species using Avogadro number. That's it. So you have to know this flow chart. Okay, are you guys clear with it? Shall we
Yes, ma'am.
discuss couple of problems related to this?
Yeah, ma'am.
Okay. So here the question is the number of water molecules maximum in which of the following? Okay, here in
18 moles of
option
water.
it is 1.8 gram of water. In second it is in second option it is 18 gram of water. Third option it is 18 moles of water, and fourth option it is 18 molecules of water. So they're asking us to compare the number of water molecules, right? So in fourth option already it is a molecule, so we don't want to do anything. But in rest of the options, we have it in weight or we have it in number of moles. The first job is we have to convert number of moles into number of water molecules, and we have to convert weight into number of water molecules. Okay, so how about this third option? Already it is a number of moles, right? So whenever we have weight, you have to convert it into number of moles, and number of moles to number of chemical species, right? And in third option, already we have it in number of moles. So please convert this into number of water molecule. So 1 mole contains Avogadro number of water molecules. Here I have 18 moles of water, which means how many number of water molecules are there? You need not multiply, you just tell the number to be multiplied. 18 into
I don't know.
6.023 into 10 power 23, right? Okay. In second option it is 18 gram of water. So first job is we have to convert weight into number of moles and number of moles into number of molecules, right? So first we have 18 gram, so weight to number of moles. So have to convert this. Number of mole is equal to given mass divided by molar mass. So here number of mole is equal to, what is the given mass of water? It is 18 gram. And what is the molar mass of water? It is 18 gram per mole. So 18 gram cancel. So number of mole is 1 mole. So it is just 1 mole of water. Right. So 1 mole of water is 6.023 into 10 power 23 water molecule, right? So this is 18 gram of water which contains Avogadro number of water molecule. In option A, it is just 1.8 gram of water. Obviously, it will be lesser than the
Lesser
second
than
option,
the
right? So they are asking about the maximum quantity. So in which option there are maximum number of water
option
molecules?
C, ma'am.
That's it. Okay, fine. So shall we move on to next question?
Yes, ma'am.
Sendamil Chelvan's answer is also right. Now we'll move on to next question. And I want you guys to solve this problem. The number of sodium atoms in 46 gram of sodium. We are provided with the weight of sodium and they're asking us to calculate the number of sodium atoms.
Option D, ma'am.
Option D. Whose answer is that? Who told me it is option D?
Me, ma'am.
Okay, Sendamil Chelvan. Okay, right, Kanna. Is there any other answer? Rakshan, what is your answer, Kana? Janani, Mariputtu?
Option D.
Option?
B.
Okay, it is option B. Second option you are talking about, Rakshan. Okay, here, okay, Marimuthu's answer is fourth option. Fine. So here, this is the weight, right? So we have to convert weight into number of moles. So how to convert weight into number of moles? Number of mole is equal to given mass, which is 46 gram, divided by molar mass. Here it is sodium, it is an element. So molar mass is nothing but the atomic mass. Atomic mass of sodium is 23 gram per mole, which is already given in the question. So if you solve this, it is 2 mole, right? They're asking about number of sodium atoms and not the number of moles. So we have to convert number of mole into number of chemical species, for which you have to multiply it with Avogadro number 6.023 into 10 power 23. So 6 into 2 is 12. So obviously answer is fourth option. Okay, fine. We'll move on to next question. The number of water molecules present in a drop of water weighing weighing 0.018 gram of water.
Ma'am,
Guys,
option D,
please.
ma'am.
Option
D, ma'am.
D. Fine. Sendamil Chelvan's answer is also option D. How about Janani, Marimuthu, Rakshan?
Option D.
Option D. So we need to convert weight into number of moles and number of moles into number of chemical species, right? This one. Which one of the following will have the largest number of sodium atoms? Largest number of atoms. So in first option it is 1 gram of carbon, second option it is 1 gram of sodium, third option it is 1 gram of lithium, and fourth one it is 1 gram of Cl2.
Ma'am, lithium-ஓட atomic mass என்னங்க?
7 gram per mole. Carbon's atomic mass is 12 gram per mole. Sodium's atomic mass is 23
Ma'am,
gram per
option
mole.
D, ma'am.
Option?
D, ma'am.
Okay, we'll check, Ram Prasad. Lithium's atomic mass is 7 gram per mole. Chlorin's atomic mass is 35.5 gram per mole. Ram Prasad's answer is option 4. How about rest of the students? Sendamil Chelvan. Yes, Rakshan?
Option D, ma'am.
Option D. Okay. We'll see, Kana. Sendamil Chelvan's answer is option C. Marimuthu, yours answer is also option C?
Yes, ma'am.
Okay. We'll check. So here they are talking about number of atoms, but here the options are in weight. So we have to convert weight into number of moles. So first option, I'm going to convert weight into number of moles. Given mass is 1 gram. To convert that into number of moles, I'm going to divide this given mass by molar mass, which is 12 gram per mole. So 1 by 12 is the number of moles, right? To convert this into number of atoms, I have to multiply it with 6.023 into 10 power 23. This gives me the total number of carbon atoms, right? In second option, it is 1 gram divided by, here the molar mass of sodium is 23 gram per mole. So this is 1 by 23 is the number of moles of sodium atom, and I have to convert this into number of sodium atoms by multiplying it with Avogadro number. In third option, given mass is 1 gram and molar mass is 7 gram per mole. So 1 by 7 is the number of moles, and by multiplying it with Avogadro number, we'll end up with number of lithium atoms. And in fourth option, given mass is 1 gram, and here it is not an atom, right? It is of course a molecule. And what is the molar mass of chlorine? Molar mass of
33.4.
no, atomic weight of chlorine is 35.5. Here it is Cl2. So what is the molecular weight of Cl2? Here these many atoms.
71.
71. So 1 by 71 mole. So this is the number of moles of Cl2, and I'm going to multiply it with Avogadro number to get the total number of chlorine molecule. See, it is Cl2. So I'm converting this 1 gram into number of moles by dividing it with molecular mass. So 1 by 71 is the number of moles of Cl2. To get total number of molecules, I'm multiplying it with Avogadro number. But here they're asking for the atoms. So in one chlorine atom, we have two. In one chlorine molecule, we have two chlorine atoms. So here I have these many number of chlorine molecules. To convert these molecules into number of atoms, what I have to do? What I have to do? In one molecule, I have two atoms, right? So in 10 molecules, how many atoms I'll be having?
20 atoms.
20 atoms. Similarly, I have these many molecules. In these many molecules, how many chlorine atoms I'll be having? Into 2. That's it, right? So now tell me, among all these options, which got largest number of atoms? For this, you need not simplify at all. See, all the numbers are same except for the denominators, right? In fourth option, the denominator is very high. What will be the original quantity? It will be very less, right? 1 by 71 will be very much lesser. Or you just simplify and let me know which got the highest number of atoms. It is very easy, Kana. Even without simplifying, we can tell.
1 gram of lithium, ma'am.
Very good, because Lithium's atomic mass is just 7 gram, right? So denominator's value is very much less. So the whole quantity will be greater, right? So 7 gram, 1 gram of lithium got the largest number of atoms. That's it. If you have doubt, then you can simplify and check also. Fine. One more question. The number of oxygen atoms in 4.4 gram of carbon dioxide is. We'll check, Marimuthu. Sentiment Children's answer is also option A. Rakshan, Ramprasad, Janani, Sharmila, Veeran. In carbon dioxide, we have carbon and oxygen, right? So here they are talking about 4.4 gram of carbon dioxide, in which how many oxygen atoms are there? Okay. We'll see. Can I listen here? We'll take only one molecule of carbon dioxide, okay? So in one molecule of carbon dioxide, how many oxygen atoms are there? Here I'm talking about number of oxygen atoms. Okay. 2. Very good. In 2 molecules of carbon dioxide, how many oxygen atoms will be there?
4, ma'am.
Very good. 4. So 2 into 2. In 10 molecules of carbon dioxide, how many oxygens will be there?
20, ma'am.
Very good. So 2 into, that is a number of oxygen in one molecule into total number of molecules, right? So 2 into 10, which is 20. So which means 6.023 into 10 power 23 molecule of carbon dioxide contains how many oxygen atoms? 2 into number of molecule is 6.023 into 10 power 23. Right. Okay. What is this 6.023 into 10 power 23 molecule? It is nothing but 1 mole. Right. 1 mole of carbon dioxide also contains 2 into 6.023 into 10 power 23. Right. But here they are expressing in terms of weight. Right. Is it possible for us to convert number of moles to weight? Is it possible for us to convert number of mole into weight? It is possible, right? What is the 1 mole of carbon dioxide? I want it in terms of gram or in weight. So 1 gram of carbon dioxide.
44 gram.
Very good. 44 gram of carbon dioxide. That's it. So 44 gram of carbon dioxide contains 2 into 6.023 into 10 power 23 oxygen atoms. But they are talking about just 4.4 gram. So it is easy to convert now, right? So 44 gram contains 2 into 6.023 into 10 power 23, which means 4.4 gram contains, it is just 0.2, right? 0.2 into 10 power 23, 10 power 23, that's it. So answer is option A. So shall we move on to next question now? You guys getting my point? So Mariamuthu's answer and Sendamal Chelvan's answer was right. So now we'll move on to next question. The number of atoms in zero point 0.1 mole of triatomic gas. Number of atoms in zero point 0.1 mole of triatomic gas. Your answer is option D, Sindhamil children. We'll check now. Okay. Ram Prasad, what is your answer? Janani, Sharmila. What is mean by triatomic gas?
Having three elements on.
A gas contains 3 elements or 3 atoms, right? For example, A, B, C. This is a kind of triatomic species, right? Okay. One molecule of triatomic gas contains how many atoms? 3 atoms, right? Here I'm writing number of atoms. So similarly, 2 molecules of triatomic gas contains how many atoms? 6, right? So just 3 into 2, which means 10 molecules of triatomic gas contains how many atoms? 3 into 10. So 6.023 into 10 power 23 molecules of triatomic gas contains how many atoms? 3 into Avogadro number. Right. So what is this Avogadro number of molecule? It is nothing but 1 mole. Right. So 1 mole of triatomic gas contains 3 into 6.023 into 10 power 23, which means 0.1 mole of triatomic gas contains how many atoms? How many atoms? That will be the answer, right, Kana? So, sorry.
0.3 cross on.
Come again, Ram Prasad.
0.3 cross.
Yes. So, in 0.1 mole of triatomic gas, 0.3 into Avogadro number of atoms, right? So the answer is.
3.
Second option,
Because,
right? So 0.3 into 6.023 into 10 power 23. That's it. Fine. Now we'll move on to next question. Okay. If 1 ml of water contains 20 drops, so 1 ml of water contains 20 drops, then the number of molecules in a drop of water is dash. They're asking us to calculate the number of water molecules present in a drop of water. Okay. 1 ml of water contains 20 drops, right? Then one drop contains how many ml? Therefore, one drop contains 1 by 20 ml, right? So you have volume. Now you have to convert this volume into total number of molecules, right? But it is not possible for us to convert directly. But what we know is, according to water, what is the density of water? Density of water is 1 gram per ml. So this is the density of water. So from this, what we can understand is, if you take 1 ml of water, then that weigh 1 gram. This is applicable only for water, Kana. Only for water, the density is 1 gram per ml. So which means if you take 1 ml of water, then that weigh 1 gram. So according to this question, 1 drop contains 1 by 20 ml of water, right? Which means 1 drop contains how many gram of water? How many gram of water?
0.2 gram.
Sorry, Rakshan.
0.2 gram.
Okay, how it is 0.2 gram? See, 1 drop is 1 by 20 ml of water. And I want you guys to express in terms of gram. And what I told you already is 1 ml of water weighs 1 gram. So 1 by 20 ml of water weighs 1 by 20 gram of water. Right? That's it. So you have weight. So from this weight, you can calculate number of moles, and from number of moles, you can calculate number of molecules. So how to convert weight into number of moles? Given mass divided by molar mass, right? So it is 1 by 20 gram. And what is the molar mass of water? It is 18 gram per mole. And you have to multiply it with Avogadro number. So what is the final answer? So what is the final answer, Kanna? Marimuthu Sendamil Shelvan's answer is second option. Sendamil Shelvan,
Yes.
Kanna, could you please tell me the total number of molecules? Number of
still
molecules
calculating.
and come again, Kanna.
Still calculating, ma'am.
It's still calculating. Okay, how about Marimuthu? Janani?
Ma'am, I'm calculating, ma'am.
Okay, Kana. Please calculate and let me know the value.
Option B, ma'am.
Second option. So, in one drop of water, it was 1.673 into 10 power 21 molecules were there. Okay, that's it. So, till now we have discussed the mole concept, and it is very very important concept. Kana, we may expect question from this mole concept. Okay, especially in NEET. Okay. In basic concepts of chemistry, we are done with mole concept now. Now we'll move on to mass percentage of an element in a compound, and after which we'll be discussing how to find the molecular formula and empirical formula of a compound. Okay, fine. First, we'll start with mass percentage of an element. It is very easy. For example, let us take water. Could you please tell me the molecular formula of water? What is the molecular weight? Molecular weight. What is the molecular weight of water?
36, ma'am.
No. It is 18 gram per mole. Because water molecule contains hydrogen and oxygen. Number of hydrogen is 2 and number of oxygen is 1. Atomic weight of hydrogen is 1 gram per mole and atomic weight of oxygen is 16 gram per mole. So 1 into 2 is 2. 1 into 16 is 16. So 16 plus 2 is 18. Right? So for this 18 gram, there was a contribution from oxygen and from hydrogen as well, right? So weight of hydrogen and weight of oxygen both were contributing for this molecular weight. So mass percentage of an element is nothing but for this whole molecular mass, how much percentage of oxygen is contributing and how much percentage of hydrogen is contributing. That is the mass percentage of an element, which is easy to calculate. I'll give you a formula. So for example, if you want to calculate the mass percentage of hydrogen in water molecule, then mass percentage of hydrogen in water molecule, the formula is number of atoms into atomic weight of that atom divided by molecular weight. That's it. Into 100, since we have to express it in percentage. That's it, Kana. So in water molecule, we have to calculate the mass percentage of hydrogen. So how many hydrogen atoms are present in water molecule? How many
2, ma'am.
hydrogen atoms are present? It is 2. What is the atomic weight of hydrogen?
1, ma'am.
1 gram per mole. What is the molecular mass of whole water molecule? It is 18 gram per mole into 100. If you simplify this, if you simplify this, we'll get the mass percentage of hydrogen in water. Similarly, we can calculate the mass percentage of oxygen. So you just apply this formula. How many oxygen atoms are there?
16, ma'am.
How many oxygen atoms?
1, ma'am.
Oxygen atoms, 1. And what is the atomic weight of oxygen? The 16 gram per mole.
Yes, ma'am.
Divided by molecular mass is 18 gram per mole
Yeah.
into 100. So From this, we can calculate the mass percentage of oxygen. Okay, this is very easy. Fine. So I want you guys to calculate it for carbon dioxide. So for carbon dioxide, calculate the mass percentage of carbon and the mass percentage of oxygen. Mass percentage of carbon and mass percentage of hydrogen. I mean oxygen. Mass percentage of carbon in carbon dioxide, mass percentage of oxygen in carbon dioxide. So what is the formula? Number of
Number of atoms into
atomic weight of that atom
atomic weight of the atom divided by molecular weight of the atom.
molecular weight of this compound into
Cross and
100.
cross.
So first we have to calculate the mass percentage of carbon.
1 into 12 by 6, 44 into 100.
So 1 into 12 divided by 44
44
into
into
100.
100.
How about oxygen?
2 into 16 by 44 into 100.
That's it. So if you simplify these, you'll get the mass percentage of carbon and mass percentage of oxygen in carbon dioxide. Fine. So shall we move on to next concept?
Yes, ma'am.
So from this mass percentage, they may ask us to calculate, or they may ask us to find the empirical formula and molecular formula of any compound. Okay. So first we have to know what is empirical formula and what is molecular formula. For example, what is this? Kana, what is this?
Benzene.
Benzene. Very good. Could you please tell me what are all the atoms present there?
Carbon and hydrogen.
Ma'am,
Come again.
Carbon and hydrogen.
Very good. Carbon and hydrogen. How many carbons and how many hydrogens are there?
6 carbons, 6 hydrogens.
Very good. So 6 carbons and 6 hydrogen. So this is the molecular formula of benzene. Now we're going to find the empirical formula. Okay. So what is the empirical formula? What is empirical formula first of all? It is the simplest whole number ratio of atoms present in the molecule. So how to find the simplest ratio? See, we have carbons and hydrogens. We have 6 carbons.
6 hydrogen as common.
We can divide throughout by 6. C1H1 is the empirical formula. That's it. So this is the molecular formula and this is the empirical formula. So in your question, they'll give you few clues in the form of mass percentage, and from the mass percentage, we have to calculate the empirical formula and molecular formula of the compound. So let us do that with a problem. See here, the compound contains 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Its molecular mass, that is molar mass, is 98.96 gram. And what is its empirical formula and molecular formula? Fine. So it is very easy, Kana. First, we have to find what are all the elements present in the compound. What are all the elements present?
Hydrogen, carbon, and chlorine.
So, hydrogen, carbon,
Carbon,
and
chlorine.
chlorine. So in second column, this is the first column. In second column, we have to write the percentage. So percentage of hydrogen is 4.07,
24.27, 71.65.
That's it. So in third column, write this percentage in terms of gram. You just write the same percentage as gram. So 4.07 gram, 24.27 gram, and 71.65 gram. Now in column 4, we have to convert this gram into number of moles. It is very easy, right? How to convert gram or weight into number of moles? We know the formula. Number of mole is equal to given mass divided by molar mass. Right. So as far as hydrogen is concerned, given mass is 4.07. And what is the molar mass of hydrogen?
4.4.
Molar mass of hydrogen. Atomic weight of hydrogen.
1 month.
1. So it is 4.07. And for carbon, it is 24.27 divided by molar mass of carbon is 12. So approximately it is, you just come up with the approximate value. 24 by 12 is 2.
2 point something.
Approximately it is 2, right? And similarly for chlorine, it is 71.65 divided by atomic mass of chlorine is 35.5. So approximately it is equal to
2.1.
is 2. Okay. So now we have to find the least whole number. It is very easy. Among 4, 2 and 2, which is the minimum number? 2. So you have to divide by 2. So you have to divide all these values by 2. So 4 by 2 is 2. 2 by 2 is
1.
1. 2 by 2 is 1. So here this is the least whole number. So we have carbon, we have hydrogen and chlorine. So for carbon the number is 1. For hydrogen it is 2. And for chlorine it is 1 again. And this is the empirical formula of this organic compound. Fine. You're getting my point? Now, from this empirical formula, we need to calculate the molecular formula, which is very easy. Kana, here, as far as benzene is concerned, this is the empirical formula, right? And this is the molecular formula. Basically, what is the molecular formula? Molecular formula is nothing but empirical formula into, as far as benzene is concerned, we have to multiply it with the number 6, right? Here, because we have divided throughout with the number 6, right? So here, as far as benzene is concerned, molecular formula is equal to empirical formula into 6 times. So generally we can write it as molecular formula is equal to empirical formula into n times. So here it was very easy, it was very clear. The number is 6 here. But here we don't know what is that n. So now we have to calculate the value of n, and to find the value, here is the formula. N is equal to, here n is not the number of moles, okay, here this is the n, and to calculate the value of n, the formula is molar mass of the compound divided by empirical formula mass. So what is the molecular mass of the compound? Is it given in the question? Is it?
98.96, ma'am.
Yes, 98.96. You should not read it as 96. It is 98.96 divided by, we have to find the empirical formula mass. We have empirical formula. From this, we have to calculate empirical formula mass. Have to calculate, here we have carbon, hydrogen and chlorine. We have only one carbon, we have two hydrogens and one chlorine. Atomic weight of carbon is 12 gram per mole, hydrogen is 1 gram per mole, chlorine is 35.5 gram per mole. So please simplify this and let me know the value of empirical formula mass. Let me know the empirical formula mass, Kanna. What is the empirical formula mass? See, everyone is telling me the value of n, but I want the value for empirical formula mass. So it is 49.5, right? So approximately, then what will be the value of n? It is 2, right? That's it. So what is the molecular formula? Empirical formula into 2 times. Empirical formula C1 H2 Cl1 into 2 times. Therefore, molecular formula is C2 H4 Cl2. That's it. Fine. Shall we move on to next question? Shall we move on to next question?
Yes, ma'am.
Here is another question. Determine the empirical formula of an oxide of iron which has 69.9% iron and 30.1% dioxygen by mass. So here they are talking about oxide of iron. What is mean by oxide of iron? It's nothing but we have iron and oxygen together, but we have to calculate number of iron and number of oxygen atoms. That's it. So this is the formula to be calculated. We have to know the value of x and we have to know the value of y, and here we need to calculate, or we need to find just the empirical formula. Okay, so rules are same, Kana. Please calculate the empirical formula of this iron oxide. So for this, you have to know the atomic mass of iron. I'll give you the value of atomic mass of iron, which is 55.85. Approximately, you can take it as 56. And for oxygen, of course, you know it is 16, right? I'll give you a minute, Kana. Let me know the simple molar ratio of iron and oxygen. Marimuthu's answer is Fe2O3. We'll check Marimuthu. Are you guys doing it or shall we do it together? Rakshan, Ram Prasad, Sharmila, Janani, Sendamil Shelvan. Are you guys working on it or shall we do it together? If you have doubt, then let me know. We'll do it together. If you are working on it, please let me know. I'll wait. Okay. We'll do it together. Guys, listen. This problem is exactly similar to our previous problem. Here, we were discussing about the elements like hydrogen, carbon, and chlorine. But here, the elements are iron and oxygen. Similarly, we are provided with the mass percentage. So first we'll write the elements which are present in the compound, which are iron and oxygen. And percentage, mass percentage of iron is 69.9 and it is 30.1. We have to convert that into, or we have to express in terms of gram. It is similar, it is same actually. So 69.9, it is 30.1. Next, what is the next column? We have to convert this gram into number of moles. So have to convert gram or weight into number of moles. Number of mole is equal to given mass divided by
Molar mass.
molar mass. So 69.9 is the given mass divided by molar mass is 55.85. Kanna, what I'm going to do is 69.9, I'm going to round it off to 70 and 55.85 to 56. Okay. And 30.1, I'm just rounding it off to 30. And we know the atomic mass of oxygen is 16. Please let me know the value of 70 divided by 56. 70 divided by 56.
No.
What is 70
1.02.
divided by 56? Yes, Rakshan?
1.02.
It is not 1.02. Partially it is right. It is 1 point. It is not 02, Kana. It is 1.25. Yes, it is 1.25. And how about 30 point, 30 by 16? 30 by 16. 1.86. Right. So among 1.25 and 1.86, which is the smaller value? 1.25. So 1.25 divided by 1.25 and also 1.86 divided by 1.25. So it is 1. And how about 1.86 divided by 1.25? 1.86 divided by 1.25.
1.488.
Okay, 1.488. Approximately, we can have it as 1.5, right? So this is 1 and this is 1.5. So here it is a decimal value, right? So to make this as a whole number, what I'm going to do is I'm going to multiply both the numbers into 2. So it will be 2 and 1.5 into 2. 1.5 into 2 is
3, ma'am. 3, ma'am.
3. So the formula is Fe2. For oxygen, it is 3. So this is the empirical formula. Or I have another way. See, this is Fe, whose value is 1. And for oxygen, the value you told me is 1.5, right? Or I can write it as Fe. For oxygen, it is 1.5. I can convert or I can write this in terms of fraction, right? 3 by 2. Here I have 1 and here it is 3 by 2. Usually in formula, the number of atoms, we will not write it in fraction or decimal. So to make it as a whole number, what I'm going to do is I should not have this denominator, right? So I'm going to multiply with a number 2 throughout. So Fe 1 into 2 is 2. Oxygen, if I'm multiplying it with 2, 2 will get cancelled out. So Fe2O3 is the formula. That's it. So this is how we have to calculate the empirical and molecular formula of the given compound. You're getting my point?
Yes, ma'am.
Yes. So we are done with mole concept and we are done with mass percentage of an element and finally empirical and molecular formula. Now we'll move on to next concept, which is called limiting reagent. What is limiting reagent? For example, I have a chemical reaction where A and B are the reacting species. Both A and B combines together to give a compound C. I've added A in a particular quantity and I've added B in a particular quantity, right? In a chemical reaction, if any of the reactants are present in a very small amount or present in a quantity lesser than the original quantity required, then that is the limiting reagent. See, we have few definitions for limiting reagent. One of the definitions is, or one of the point of view is, in a chemical reaction, if any of the reacting species quantity is lesser than the quantity actually it was needed, then that is the limiting reagent. And That limiting reagent will decide the quantity of the product formed. And third point is once the chemical reaction reacts come I mean once the chemical reaction is done, the limiting reagent will be consumed completely. Okay, so we can see 3 point of views of limiting reagent. So the first point is this is the reactant whose quantity will be lesser than the quantity actually required. And this limiting reagent will decide the quantity of the product formed. Once the reaction is completed, the limiting reagent will be completely consumed. So this is the limiting reagent. Okay, for example, I have a company which manufactures a pen. Okay, so I have two departments for that. This is department one, where I'm manufacturing only pen, and in second department I'm manufacturing only cap. But what is the total finished good is pen plus cap. This is the complete product, right? So at the end of the day, I have 25 pen, and end of the day I've manufactured 100 caps. So how many complete pen will be manufactured in a day? How many complete pen will be manufactured in a day? In department 1 I've manufactured only 25 pen. In department 2 I've manufactured 100 caps. But how many complete pen was manufactured? Whole pen is nothing but
25.
pen plus cap, right? Yes, Ram Prasad?
25, ma'am.
Very good, it is 25. So, in this process, we need 100 pen actually because I have 100 cap. But this is the material whose quantity is lesser than the actual quantity required, and this decides the product's quantity. And once the complete process is over, all the pen was consumed, right? So here pen is the limiting reagent. You're getting my point? You're getting my point, Kana?
Yes, ma'am.
Fine. Now we'll discuss only one problem related to that and we'll wind up the session. And in next class we'll be discussing few more problems under limiting reagent. Here is the question. Calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air. Here they are talking about a process where carbon is burnt in air. So carbon is one of the reacting species and it is burnt with air. See, we have to produce carbon dioxide. So what will be the compound which reacts with carbon? It is nothing but oxygen. So oxygen which is present in air reacts with carbon to form carbon dioxide. So this is the chemical reaction. So whenever you are writing the chemical reaction from the process, please make sure you're writing the balanced equation. Is it balanced, Kanna? Is this reaction or is this equation balanced?
Yes, ma'am.
Yes. So from this, what we can infer is in terms of number of moles, 1 mole of carbon is reacting with 1 mole of oxygen to give 1 mole of carbon dioxide. So this is in terms of number of moles. And what is the given data? In first question, 1 mole
One
of
mole
carbon
of carbon is burnt in
air. So they are talking about air where the oxygen's quantity is unlimited. So we have so much amount of oxygen, so we need not worry about the quantity of oxygen there. And now they're asking us to calculate the amount of carbon dioxide. So for 1 mole of carbon, how many moles of oxygen required?
2, ma'am.
For 1 mole of carbon, how many moles of oxygen required?
1 mole.
1 mole. In air, definitely we will be having 1 mole of oxygen, right? So 1 mole of carbon is reacting with 1 mole of oxygen to give 1 mole of carbon dioxide. That's it. So for first question, the answer is 1 mole of carbon dioxide. Could you please tell me 1 mole of carbon dioxide is how much gram of carbon dioxide? 1 mole of carbon dioxide is how much gram of carbon dioxide? 1 mole of carbon dioxide. It is not 12 centimeter, children. It is 44 gram of carbon dioxide. Okay. So this is the answer for first question. Second question is 1 mole of carbon is reacting with 16 gram of O2. See here, what is our inferences? 1 mole of carbon is reacting with 1 mole of oxygen. But in our question, the data is given in terms of weight. See, please convert the data into number of moles because all our inferences in terms of number of moles, right? So what is 16 gram of oxygen? I want it in terms of number of moles. 16 gram of O2 is nothing but how many moles of O2? 16 gram of O2 is nothing but how many number of moles of O2? Number of mole is equal to given mass divided by molar mass. So given mass is 16 gram, molar mass of O2. Molar mass of O2. See, O2. We are talking about O2. Atomic weight of one oxygen is 16. So we have 32. Yes, it is 32 gram per mole. So 16 gram of oxygen is nothing but 0.5 mole of oxygen. See, our ratios, carbon and oxygen were reacting in 1:1 ratio. Here in the second question, I have 1 mole of carbon, but I have just 0.5 mole of oxygen. So which is the limiting reagent? Which is the limiting reagent? Whose quantity is lesser than the quantity required? For 1 mole of carbon, we are in need of 1 mole of oxygen. But in this question, we have 1 mole of carbon, but how many moles of oxygen we have? It is just 0.5. So here oxygen is the limiting reagent. And oxygen's quantity will decide the quantity of carbon dioxide formed. So according to our inference, if the oxygen's number of mole is 1 mole, then carbon dioxide formed will also be 1 mole. And here in this question, number of moles of oxygen is just 0.5 mole. Then what will be the quantity of carbon dioxide formed? What will be the number of moles of carbon dioxide formed? If oxygen is 1 mole, then carbon dioxide is also 1 mole. Here in our question, number of moles of oxygen is 0.5. Then what will be the number of moles of carbon dioxide formed? It is also 0.5 mole, right? That's it. For second question, the quantity of carbon dioxide formed is 0.5 mole or 22 gram of carbon dioxide. That's it. And this third question is your activity. Here 2 moles of carbon are burnt in 16 gram of dioxygen. Again, you have to convert 16 gram of dioxygen into number of moles, and you have to compare the number of moles of oxygen with number of moles of carbon, and you have to find which is the limiting reagent, and limiting reagent will decide the quantity of product formed. Okay, you're getting my point? So today we have discussed mole concept, how to convert weight into number of moles and number of moles into number of chemical species, after which we have discussed the mass percentage of an element, How to calculate empirical and molecular formula, and finally we have discussed limiting reagent. And from in next class we'll be discussing the problems related to limiting reagent, and we'll be discussing solutions, concentration, and parameters to express concentration and problems related to that. Fine. So shall we wind up the session?
Yes, ma'am.
Yeah, ma'am.
Okay, Kana. Okay. Bye, guys. Bye bye.
Thank you, ma'am.
Thank you,
Good
ma'am.
night. Good night, Kana.
Thank you, ma'am.
Bye, Sandhamid children.
Thank you, ma'am.
Sir? Sir?